So you should.
Hey,
Hello, how are you doing?
I'm good. So, how are you, Katie?
All right. Yeah. Do you want to
Cool.
introduce yourself?
I do, yeah. So, I'm Ben. I'm a learning manager at the Raspberry Pi Foundation. I am our lead educator on our Experience AI program.
And I'm Katie. I'm program coordinator and general organizer of things here at the Raspberry Pi Foundation. Welcome to our Experience AI webinar. Ben, this is an exciting milestone for us. It's a chance to show off all the hard work we've done so far.
Yeah, it really is exciting. So, thank you so much for joining us for this webinar. And in this session, we will talk you through what is available for our free resources on machine learning and AI for our program called Experience AI. And we have a series of webinars planned for you over the coming months. But for our very first one, we wanted to do a deep dive into some of the key areas of each lesson to give you some little hacks on how to get the most out of the lessons with your students.
The webinar is to support you. We really do want your input. If you have any questions, or perhaps you've even taught some sections already and have some hints of your own to share, you can post them in the chat or submit them via the link below.
Cool. So before we get started, Katie, I'm going to let Salome introduce the Experience AI lessons to everyone here today.
Sounds good.
What is artificial intelligence? With the rapid advances in AI and machine learning, it's incredibly important that young people understand how this technology is affecting their lives now and the role that AI applications will play in their future. The Raspberry Pi Foundation and DeepMind have partnered to create everything you need to learn about this exciting, cutting-edge technology. Enable your learners to understand what AI is and investigate a variety of applications through practical activities, to think critically about the societal impact of this technology on their lives and future careers, and explore ethical considerations through classroom discussions of real-world contexts. These lessons have everything you need to inspire young people through the power of AI. Lesson plans, presentation slides, educational videos, and worksheets, all for free. Sign up now at rpf.io/experienceai.
She makes them sound really good. And what a lot to cover in just 6 lessons. So as Salome said, Experience AI is a unit of free lessons all about AI and machine learning. We are the Raspberry Pi Foundation. We're a charity based in the UK, and our mission is to enable young people to utilize their full potential through power of computing and digital technology. Experience AI is the outcome of our collaboration with Google DeepMind, industry leaders in the development of machine learning systems. And we're also partnering with the University of Cambridge. They're doing research on how to make teaching and learning of AI and machine learning effective. So as we said, we created a unit of 6 lessons. They've been designed for 11 to 14-year-olds. We know some of you may use them for different age groups. And the main aim is to improve engagement with AI and to gain an understanding of its impact on the world, as well as an awareness of AI-related careers. We really want to encourage young people who are underrepresented in AI to see the potential of the technology and the role that they can have in future developments. So, shall we start and have a look at the lessons?
Yeah, that sounds great. So there we go. So this is an overview of the lessons that we have in the unit. And you can see there are 6 lessons, and we aim to be roughly between 50 minutes to 60 minutes in length. So you can see we cover a whole breadth of things to do with AI and machine learning, where we start off covering what specifically is AI. We look at the social implications of AI technologies. We also like to explore some of the ethical benefits and disadvantages. We look at bias. We focus on machine learning models such as classification, look at decision trees. And finally, in the last 2 lessons of the unit, we take the students through their own AI project where they develop their own machine learning model to solve a real world problem of their choice. And at the end of the unit, we finish off to hopefully get them excited about their futures and a career in artificial intelligence.
They're going to be busy. That's all I can think.
But busy fun in a good way.
Exactly that. So how do you find these lessons? We've got a lovely rolling banner down here. rpf.io/experienceai, and that will take you to this webpage. So you've got a couple of options. You can either click on the lessons at the top, you can explore the lessons through the big blue button. There's even a section here for explore the lessons and various other bits as well that we've been doing throughout the project. So let's explore the lessons. What we've got here, we've got the unit overview. If any of you have used the computing curriculum, you might have seen that we create learning graphs for our units, and that will give you an idea of the skills and knowledge that hopefully students will learn and progress with throughout the unit. The ever handy glossary of terms. There's been a lot of pedantry corner about those terms. They've been very well thought out. And then the 6 lessons themselves. If you click within each lesson to view the resources, you'll find the learning objectives, key vocabulary, and the lesson structure, and all the resources that you will need to deliver that lesson in a range of different formats.
Cool. So should we move on to the lessons themselves, Katie?
That sounds good to me.
Great. So the first lesson is what is AI? And now throughout the unit, we've worked on a theme of having something for you to display to your students to get them thinking about the lesson the second they enter the classroom. So for lesson 1, we start off with this fundamental question of what is intelligence? So Katie, what do you think? That's an easy question so early on in the webinar, right?
Oh yeah, great. Big question for a Monday, Ben. I'm thinking immediately of those tests of birds, flapping their wings and recognizing themselves in mirrors. So perhaps it's the ability to learn and test things.
Cool, that's actually pretty good, Katie, for a Monday. Very, very well done. So there's no real right or wrong answer here. And actually, this is one of these questions that researchers and scientists have been debating for a long time. But it's actually a really good way for your students to start thinking about AI and what their capabilities are as human beings. So what we've landed on is this definition of the ability to learn, adapt, and react to new situations. So not too dissimilar to what you just said there, Katie. So this actually leads on to an activity called the intelligent piece of paper. Now, this activity is one that we borrowed from Paul Curzon from Queen Mary's University in London. So let's take a look at that and how it fits in the lesson.
So this is the exact slide directly from the lesson. And this is where you will get your students to play a game of noughts and crosses, or tic-tac-toe if you're from not England, probably. That's it. Yeah, isn't it amazing? We all have different names for the same thing. So this is noughts and crosses, tic-tac-toe against a seemingly intelligent piece of paper.
So what they'll do in this activity is they'll come to this conclusion whether the piece of paper actually wasn't intelligent, although you've got to play a game to pretend it is at the beginning. But what you're actually doing, or what this piece of paper is doing, is just following a simple set of if-then rules. Now, if-then rules are things that your students may well be familiar with if they've ever done any kind of Scratch or Python programming before. But the fundamental principle for this unit is that students understand the difference between a rule-based approach to programming, such as the if-then rules, and this new data-driven approach, which is the foundational concept behind most modern-day machine learning models. So the data-driven approach, like I say, is taken by these modern-day AI systems, and that's a really fundamental concept that we really want the students to grasp right at the beginning of lesson 1.
In one of our future webinars, we will explore this concept in more detail. But for now, we want to jump ahead into the lessons to talk about one of the more practical activities in this lesson, where students get hands-on using an AI application. Your students will get to use an online AI application to generate art, something that we might have seen a lot in the news. And whilst Ben is talking about the lesson, I'm going to have a go at making some art.
Cool. Okay, so you can see there, this is an actual website that we've got linked inside lesson 1. And so Katie's opened this. Now, the task that we want to give the students is we're going to ask them to create an AI, so use an AI application to generate artwork for either a poster for a World Climate Change Conference or the wall of a cafe or a restaurant. So which one are we going for, Katie?
I'm going to go with cafe because I can think of lots of different keywords that I can use for that.
Okay, so what I want you to do, Katie, is think about what's your ideal cafe? What would you expect to see on the wall of that cafe?
Oh, I'm not sure what I expect to see on the wall, but I definitely want something that's probably got a teapot with it, maybe a cup and something with a cake in there. I think I'm going to try and use the word vintage, see what that comes out with.
Okay.
And then what kind of style do I want it in?
So you can see as Katie's scrolling down here, we've got this website where some of them, there's the kind of premium model, which requires you to log in and pay for it. But we don't expect to do that with your students at all. So you can quite happily use this website with the free version. It's worth noting that this is the one that we've gone for in the lessons. If you know of a better one that generates art, you can swap that into this lesson as well. And these things are constantly changing as well. So we do keep an eye on these websites to make sure they don't just randomly change their model and all of a sudden everything is have to pay for. So if that does happen, we'll keep an eye on the lesson resources and we'll update them as soon as we can. So anyway, Katie, let's generate that artwork. Let's see what it comes up with.
So I picked a fantastical thing. Let's see what we get. Okay. I don't know what I'm expecting. I've got teapots. Okay. Can I make that big?
Yeah.
Is that what that button does?
So
there it is.
There we go. There you go. Yeah, that's cool. So it's actually done not a bad job. I'm not sure. I think that looks like poster-like. So what we could do if you were talking to students about this is maybe encourage them to like change their prompt a little bit to make it more poster-like. And they can enter free text into this box at the top. So if you wanted to generate that artwork again, you could do trying like a different style as well. But the questions that we want to pose the students whilst they're making this, so that kind of twig little thoughts in their brain, is I want you to say to your students, if you're doing this activity, is, well, who do you think owns this artwork? You know, who actually made the art? Was it you or is it the application? And maybe what are the problems with using AI to generate artwork for you? Do you have any thoughts on these, Katie? Who owns this art, do you think?
Oh, so I've been thinking about this because I've given it the key terms, which I suppose is a bit like I commissioned a piece of artwork from the AI. So I'm not sure if it's me that owns it. It's possibly me that's directed it. And then
if anybody else has the answers, by the way, in the chat, if you're watching this and you've got a thought on this, please put your comments in the chat.
Yeah, I mean, I guess because if I'd have asked it to do, I don't know, like a Van Gogh type tea room something, does Van Gogh then still own that artwork because it's inspired by? But then equally, people do build on these things, and I'm starting to wonder about what's the data that it's got behind it, because it doesn't.
Perfect. And if those are the kind of questions that your students are asking in your class, that's absolutely brilliant. You're getting their mind thinking about the right thing at the right time. Really what we're trying to get down to is the fact, again, there's no right or wrong answer here as such, because these things haven't been decided in society yet. But where the unit's taking the young people is to learn about kind of to ask questions such as what data is used to build these applications? Who did own the artwork? Did they ask permission of the people to use that to train their model? Because in theory, there's a lot of ways in which we could say that actually the way the artwork has been generated might be similar to how we as human beings do. And we look at other people's artwork, we kind of repeat the style, and then we make it our own. So there's an element there where the prompts, you are making something your own. However, you know, you didn't make the application. And I think, as Catherine just pointed out, the AI tool might own the artwork. So this is something that we need to be careful about when we're trying to pass off these kind of work as our own.
I do wonder, though, could you make the same picture from the same inputs?
Why don't we give it a go?
Let's try. I'm going to hard refresh my screen. Let's see, what did we have? I had teapot, cup, cake, vintage, and I picked the one with the rabbit. Here we go. What do we get? Cars this time.
Yeah, that's like.
I'm not sure I'd use it on my cafe.
No. So again, it goes on to who about this. What are the problems of using this? I mean, if you were an artist or you were an illustrator, Katie, would you be worried about this kind of technology?
I'm not sure I would, because it still doesn't. You know, like there's rooms for many different types of art and different types of artists, and I guess it just depends on what people want. Maybe it's a jumping off point.
Maybe it's a tool that support the artist and help them with their creativity as well, right? So yeah, again, with all these kind of things, these are just prompts you can ask the students. Let the students come up with their own ideas. There's no right or wrong answers here, but we really just, this is lesson one. We want them to start thinking about the implications of these tools and the technology that behind them. So let's move on then, shall we, Katie?
Yeah, and I hope that gives you some ideas how you can have similar discussions with your students. So next up, Lesson 3, bias.
Yeah, let's dive into lesson 3, bias. Okay. So first up, let's introduce you to a scenario. So we skipped lesson 2 a little bit because, like I say, we're giving you this whistle-stop tour of the units. So we skipped lesson 2, but moving into lesson 3. Now, right at the beginning of lesson 3, we have this scenario to give to the students. And the scenario is a national supermarket wants to save shoppers time at the checkout, and they believe that an AI application can help them achieve this. But what they want to do is use cameras around their stores to recognize the items that customers are placing in their baskets from the shelves to recognize what they've put in, what they've collected.
So the supermarket has asked you to create a model that will only recognize apples and tomatoes to see if the idea will work. What do you think we're going to need to create our model, Ben?
Well, that's a good question. So what we've learned so far is these machine learning models require data because they're data driven, right? So it needs lots of data to train this model. So it mentioned that there are cameras around the store. So I reckon the data is going to come from the cameras. So we probably need image data, right? Images of the apples and tomatoes.
I think you're right. Shall we have a go at making the model?
Yeah, let's do this. Yeah, definitely. So we're going to create an activity. We're going to do this activity just like your students would, and we're going to create a classifier that's going to classify apples and tomatoes. And I really like this activity, Katie, because it's the first time in the unit where the students will make their very own machine learning model. And to do this, we're going to use this tool that you can see on screen now called Machine Learning for Kids, which is completely free. So how you do this, Katie, let me talk you through it. You go to Get Started.
Yep. Okay. So I'm on the Machine Learning for Kids website. I'm clicking on the blue Get Started.
Now, again, what we really like about Machine Learning for Kids is it's an absolutely fantastic application for young people to get started with building machine learning models. But also for this unit, you don't need to get your students to log into it or create an account. You can, because it's one-off activity in the lesson, you can click on Try It Now.
Yeah, I'm going to go down that route. There we go.
Cool. So they want to create their model. So at the top right, yeah.
Add a new project.
Add new project, sorry, yeah. Now this project is, we can give it a name. Let's call it Supermarket AI.
I'm going with Supermarket, yeah. And
now we talked about the type of what data we needed before, so that was images.
I think I'm going to be checking out images because I'm looking at recognizing those images of apples or tomatoes. And then I'm assuming that I'm clicking the create button.
Yeah, that's right.
Here we go. Lovely. Right. I've got a project.
Cool. So let's get started on that project. So if you click on that, and then we're going to train our model.
Excellent.
Now, we said we wanted this model to be able to classify apples or tomatoes. So to train our model, we need images of apples and tomatoes, but we need a place to classify them. So we need to set up our labels, essentially. So there's an option at the top right-hand side there, Casey, for labels. And let's call our labels tomatoes.
Here we go, testing my spelling as well for a Monday. Typing. Here we go.
Cool. So in this lesson, we've got a website that the students can be linked to that has a set of training data. There we go. So you can see the training data. Now, these are a bunch of apples and tomatoes. So what we need the students to do is to look through the images and select 5 examples of images of apples and 5 tomatoes. So all they need to do to add one in, Katie, you just grab a picture of an apple, anyone, and drag it into the apple class. Apple label.
I'm going to go with that first one.
Cool. So we label the data, simple as that, just dragging and dropping into there. But we want the students to really think about the apples and tomatoes that they're picking, right? Because they want to think, well, this is for a supermarket. So what would be kind of representative data? What data would it be likely to see in a supermarket?
I'm not sure I'm going to be seeing an angry cartoon apple, but I really might see
like the angry apple.
Tomatoes. Maybe it's, got one of those kind of fancy farmer's bucket style things going on. So I could see that. This looks pretty much like what I might see in a supermarket. Similar for my apples. How many images do I need, Ben?
5 of each. 5.
Excellent. Right. I've got 3 of each. That looks pretty supermarket-y. One on its own. Right. I've got my 5 tomatoes. 1, 2, 3. Apples. There we go. And I'm going to put in a curveball of 1 on a tree.
Cool.
There we go.
Okay, so now you've set up your training data. So it's time to train a model. Let's create our first machine learning model. So if you go back to projects at the top there, and then
Lovely.
learn and test.
Yep.
Okay, and then you can see there's a big blue box there that says train machine learning model. So you can click on that. Now that normally takes 10 to 30 seconds to do. And you can see, and eventually it'll create your machine learning model. But the next thing we need to do is test that it works. We need to see how effective or accurate our model is. So what we've done is we've also provided some test data for your students. So if you scroll down on the website on the left-hand side there, Katie, you can see we've got some test data.
Right.
Now, the more eagle-eyed students amongst you, in fact, Katie might even spotted it as well. Do you notice anything a little bit different about my training data compared to the the test data compared to the training data?
I've only got one picture of green apples. I had a lot of green apples in the in my training data.
Right. Okay. That's so perfect. So you spotted, and your students might spot it too, that we've only given you images of green apples to train your machine learning model. We haven't given you red apples. So let's see what impact that has there, Katie. So can you see that one of the tree there, tree of the red apples? Let's see how well it does with that.
No, this tree one, not the one with the barrels.
Yeah,
right.
yeah. Now there's two ways in which you can get test it. You can do what Katie's doing there. You can drag and drop it, and you can see it creates a little URL in there. So we'll do that one first. I'll show you the other method of doing it later. So if we test that.
Okay, so it thinks it's possibly a tomato. 70%. So it doesn't think. The data has decided that it is. It's 70% confidence that it's a tomato. That's really hard to not people, that one.
Cool. Yeah, and that's one of these key things that we put in the unit. It's this thing that we call anthropomorphization, which is the humanization of these machine learning models. All the language that we try to put inside the unit is try to avoid this issue of trying to humanize these things, because machine learning models are not embodied people. They're not thinking machines. They're not the Alexa, although whilst your smart speaker at home might be talking to you, there's no person behind it. So the language we're trying to use is to make them sound like they are machines, which is exactly what they were. What they are, sorry. So the model has output that we've got, it's a tomato. So it's incorrectly classified that data. And I'm quite confident as well, right, Katie? 72% confident?
I mean, I've still got 0.25% that I might get an apple at that.
Maybe, yeah, okay. So, but maybe if you were in charge of the supermarket, you're not going to be happy with that. You're not going to use this model, right? So but that's only one image, right? Let's test it with some other ones. So let's try another apple.
I'm gonna go with the big red apples in a barrel. That did it this time. I'm gonna try the other way. So what we can do is that we can copy the image address. There we go, and then paste it in here.
Because sometimes it can be a little tricky to drag and drop into that space. So you can right-click, copy image address, and just paste into there. And what's it saying this time, Katie?
89% confident that it's an apple.
Right, so it's got it that time. Okay, that's so the output there is more accurate and it's more confident. So we've probably got some disparity. So let's do the final push. Let's give it a go with a tomato.
I'm wondering if it's because all my tomato pictures, I didn't have tomatoes in a barrel. I didn't have any images of something on a black background. So I'm going to go with this one of my. Is that even a tomato image? I'm not even sure. Copy the image address. Here we go. Paste. And that thinks it's a tomato, 60% confident. But then when we did 60% confidence of a tomato, it was actually an apple.
If you were in charge of the supermarket and you were you were the boss of the national supermarket, Katie, what percentage confidence would you want this to have to make sure that you were ready to use it with the customers?
I mean, ideally you'd want 100%, wouldn't you? But I mean, that's a lot of data. That's a lot of model training to get.
There's a lot of data, yeah. So, and as Duncan has pointed out, it really does show the importance of what the training data is. So we have this rule with classification models. Broadly, the more data you provide in the training data, and the more representative it is of the real world, the more likely it is to be an accurate model. So we talk about confidence scores there, which is a really interesting thing, which we also just explore throughout the whole unit. And we earlier, Katie and I were having a conversation about this, and we're talking about driverless cars. Now, if you had a driverless car that was wanted, and you wanted the driverless car to be able to predict whether or not the cameras were picking up a human being, how confident would you want it to be? Would you want it to be 100% confident it's a human being? What do you think, Katie?
Do you know what? No, because if it only 6% thought that I was a human, and the implication is that it might run me over, I don't want to get run over.
Yeah, exactly. So maybe it depends on the model that we're using. For the supermarket, we might want to be close to 100%. But if we were a driverless car, maybe want it to be less confident before it takes evasive action, before braking or hitting or something like that. So yeah, so this confidence score is a really interesting one because yes, absolutely want it to be the data to be labeled accurately, but the confidence score really does depend on the application using that model. Great. Okay, so that was an example again. And what we do is this moves on nicely to conversations that we have around bias. Because whilst in this example, we're only talking about apples and tomatoes, and it wasn't always 100% accurate, it's because this data is not representative of data that this model would be exposed to. So what would that look like if we were dealing with a facial recognition system and different skin tones? So that's where the lesson goes into in terms of bias. So yeah, Katie, let's move on.
Yeah, let's go. I mean, this was really good. I enjoyed doing it. And that's my first proper machine learning model that I've done. And it's definitely made me think about what data I'm putting into my model. So the next topic is all about projects, lesson 5, lesson 6.
Cool. Okay, so what would we cover in lesson 5, Katie?
So lesson 5 is we are solving problems with machine learning models. So we've had a little go at building a machine learning model. Now we need to think about what the AI project lifecycle is so that we can actually get a model that we think is doing the job that we want it to do. How do we do
great.
it?
And yet again, I'm going to let a Google DeepMinder do the talking this time to show you what's involved in the AI project lifecycle.
The typical AI project has 6 stages. It starts with defining the problem, then we move on to a phase where we collect data and prepare the data, then we do a training of a model, we test it, we evaluate it, and eventually we want to explain the model.
Excellent.
Perfect.
So at the moment, we have 2 projects on offer for your students to choose from, and we're hoping to add more soon. Here we go. So they're the 2 projects that you can have a go at, classifying data from the world's oceans or identifying fake news.
Okay, Katie, if you were going to pick one of these, which one would you pick? Which one sparks your interest the most?
I'm probably going with oceans.
Cool. Okay, well, let's talk you through some of the worksheets that we would need for this. So the students get provided with some worksheets no matter which project they pick, and we are looking to expand on these projects. We've got 2 at the moment, but we're working on providing more. So provide your students with a little bit more choice to solve a project that really kind of, talks to them, and one that they would like to solve, that they might feel good about. So if we were taking the one that Katie picked, which was classifying the data from the world's oceans, so this is a project called Argo. So it gives them a little bit of information about the project, what specifically the problem is, and the task is to train a machine learning model that will predict the location of a float that has failed to send back its location data. And that this document provides a little bit more context about what those floats are. And with each worksheet, we have this part at the bottom, which gives you a sample of what the data would look like from the training data. When they produce their project and they go through all those stages, as we explained before, we have a worksheet for them to work with throughout the 2 lessons, where they complete the stages and document their progress and the results of the training and the testing of their model. So they need to create this document and complete it as they're working through the stages of the project lifecycle.
Excellent. So at the start of the AI project lifecycle, it's all about defining the problem. They are choosing a problem that's already been defined, but we think it's important to teach students to take a user-focused approach to creating the solutions to problems using machine learning. So we're getting students to think about that end user. So here we have the United Nations Sustainable Development Goals. And what you can do as part of the lesson is to consider your projects and why is a data-driven approach the appropriate choice for these problems.
Cool. So Katie, now that we've picked the project and thought about the users, where do I get the data set that I need to train the model?
That's a great question. The data is actually embedded within that free online application, Machine Learning for Kids, the one that we've already seen. Do you want to take us through how to train the model?
Yep, sounds good. Let's do that. So back we go to machine learning for kids. So we use this in lesson 3, but they also use it in lesson 4, lesson 5, and lesson 6. So again, without the need to log in, they can just click on Get Started and try it now. Now this time, rather than go to add a new project as Katie did, we're going to go to copy templates. Now these are pre-built data sets, so it saves the kind of need for your students to upload any data to this platform. We created the data set for you. So if you click on copy template and scroll down, you can see a bunch of projects. And here's the one that we've got at the moment. So ocean data is the one that we're going to work on with today, Katie, but there's a fake news data set if you're interested. And here's a data set we use in lesson 4 when we covered decision trees that you ask your students to load up. So with the ocean data project, it's really as simple as just going import. Now, the first thing it does, it asks you is how much data do you want to set aside for training? So part of the lesson structure is just explore the concept of splitting a data set into training data and test data, much like we did with the apples and tomatoes. So we want to give the students a bit of autonomy here, where we ask them to think, well, what percentage do you think will be appropriate for your model to set aside as training data? For test data, sorry. So we click this box. We do want to use some of the data for testing, and we have a slider here to select your percentage. So let's say for now, a good starting point is about 20%. So I'm going to select 20% for my testing and click import. And you can see I've got my project loaded up. And you can encourage your students to go and look at the data. So if we click on train there, you can see the data has been classified already, and we can see we can scroll through and just inspect that data a little bit. But what we actually want to do is train this model. So I'm going to click on learn and test again, just like the apples and tomatoes, and train the machine learning model. And like I say, yet again, that took about like 3-4 seconds. Sometimes if it's text, it might take a little bit longer, but certainly not a significant length of time. But even if it takes a minute or so to do, you can encourage the students to download the test data. Because what it does, if you click on that, it creates a CSV file of the test data. So I'm going to click on the download there. In fact, I'm just going to share my screen in a second. So excuse me a second, whilst I present my full screen rather than just a window. Here we go.
Not enough windows.
No, never enough windows. Okay, so you can see here, here's my my test data here that I've got. Now, I've highlighted one in advance here, so I'm just going to use this at random to decide on that's going to be the data that I want to use as my test data, just as a one test. Again, with your students, you'd encourage them to do at least 10 tests, but this is just going to be one for demonstration purposes. So I have temperature of this amount and salinity of that amount. So I'm going to select my temperature. I'm going to copy that and paste it into the temperature box. Go back to it, and I'm going to select my salinity, and I'm going to paste that into there. Now, what we're hoping for is that it will label it as tropical. So let's see if it does that. So I'm going to test it. And perfect, 100% confidence is tropical. So that shows my machine learning model has worked with that one test. So your students would need to go through that and test a little bit more just to see whether or not that one test is accurate, reflective, and we can work out accuracy from there.
I guess that's still similar to science lessons of you want to test things a couple of times to actually gain an average to see how well your model's working.
Yeah, exactly right.
These are still quite familiar structures for how we're testing and building things.
Yeah, perfect. Exactly right, yes.
Excellent. So in this lesson, the students will complete the stages of an AI life cycle and evaluate the model they have made. And they'll do this by making a model card. Ben, can you talk me through a model card?
Yeah, perfect. I will do. So model cards are an approach for describing a machine learning model. And the idea is that every machine learning model should come with a model card, so it provides information to help people evaluate how effectively the model will work with the data being used.
So a bit like the information you get on food packaging, and it provides the transparency over the content so you can make informed choices. Yeah,
exactly that. It's just like, that's a really good analogy, just like a food packet. So the idea is you're making these informed choices, and that's the same with the model card. Once the model has been developed, we should make it as transparent as possible for the user of this data to see whether or not this is the right model to use with their application or the data that they want to use. So here's an example of a model card, and it's one from Google, and it's a face detection model card, and it outlines the example uses that can be used with it. It outlines what data should take. But what I really like about this model card is this transparency of what are the known limitations. So Google here being super transparent about what they think are the limitations of this. This is where you shouldn't use the model, or if you do use the model for these reasons, why it might not be as accurate as you want it to be. So I really like that. I think that's really good. And this is, you're going to ask your students in your lesson to use this exact model card as well to with a scenario before they actually then build their own model card. So you can see on screen here, we've got an example of a model card template. So once they've seen the example Google one, what we want them to do is complete their own model card for their own machine learning model that they have built. Cool. So then after we've done that, we move on to the final part of the unit, which is AI careers.
So things change quickly in technology, but what is relevant for your 11-year-olds now is that maybe that those things look really different in 5 years' time. However, AI technologies are only going to become more prevalent and more, just more around in everyday life, and they will have an impact in the careers that they're going to have. So what we want to achieve in this section is for students to be excited about the role that AI can play in their future careers.
Yeah, exactly that, Casey. I think it's really important to recognize that AI is a part of all of our futures, not just our students, but certainly our students' futures. And we really want them to feel inspired that they can play an active role in their futures and not just be a passive consumer of this technology. So we want to use this part of the lesson to inspire your students to think about not only their future careers that might involve AI, but maybe even careers in AI.
That sounds brilliant. And what a great way to end the unit. So let's show you an inspiring video that you can show your students.
Creating AI applications requires lots of different people with diverse skills, personalities, and experiences, working across a variety of jobs and careers. I wonder what draws people to explore the field of machine learning. What's it really like to work in AI? And what can we get excited about for the future?
It's great to have something to wake up in the morning for, and knowing that hopefully one day that the sort of models that my team builds could hopefully impact like a little bear in the woods.
I get to play with robots every single day. What's not to like about that?
I feel that the problems I get to work on are actually important for the world. I feel like there's kind of a real purpose to what I'm doing. And also, like, I get to work with really great people.
Every single day, we get to apply cutting-edge technology to the world's most pressing problem, or what I think the world's most pressing problem is, which is climate change.
Probably like more artsy than you'd expect. My wife disagrees that I'm an artist. I claim I am, and it's very creative and so on.
This was something that when I joined DeepMind, was quite surprised to find, is really that there are a wider diversity of people in different roles here than almost any company I've ever worked in before. And the nature of AI is, if we want to use it as a tool to solve this wide range of problems, then we need input from people from all sorts of different jobs because they're experts in their area.
We are just beginning to scratch the surface of the exciting industrial and scientific discoveries that can be done with models like these.
The potential benefits of like science and healthcare really, really exciting, because that's where I guess it, at least like on the surface, seems to change people's lives for the better the most. The models can help us invent new kinds of medicines, or maybe it can help us develop kind of technology that we can't even imagine today.
I hope that the work we do can kind of decrease inequality by, there's a number of routes to this. So there's obviously reducing the repetitive tasks that some people have to do, but also there's ways that we can use AI to help people communicate better, to come to decisions.
Don't underestimate the applicability of AI for whatever that might be. I wanted to work in climate change mitigation and adaptation, and it's not necessarily the first place that one might think of applying AI, given technology and the environment.
Even if you're not necessarily in this STEM area, I would highly encourage you to get on top of the trends if you find it interesting, and certainly join the conversations. It's not just that we would like to hear from you, I would say we need to hear from you.
So I think it's very important that people with different interests and different backgrounds get involved, because otherwise we won't be able to build good AI for the future.
Even if you don't think AI is what you want to do, figure out what it is you want to do, and then just ask yourself if there's an application of AI, because you might be surprised.
You can do it. We try to be as open and inclusive. It's really open for anyone. And I truly believe that.
So, no matter what your interests, passions, or skills are, you can find an exciting future in the field of machine learning. Artificial intelligence is for everyone.
Oh, I really love that video, Katie. That's my favourite.
I know. I'm just wondering, is it too old to make another career change? But you know.
Yeah, so hopefully your students will also feel inspired by that video too, and feel like, you know, the AI is a place for them. And what's something we really want to achieve is the fact that improving diversity in the tech industry is super important. So being exposed, these videos and these lessons being exposed to as much of a diverse range of people as possible would be perfect. Because that's the way we're going to make a difference in the world, isn't it, Katie? We're going to make a difference by making this tech field a diverse place. That's how we make better machine learning models, right?
More different types of people around the table, or, you know, at the computer or working remotely.
So Katie, did we have any questions come in during the webinar that we can answer now?
Yeah, we had a brilliant one from Ken, and he has said, maybe I missed it, but are there plans to include ChatGPT in a future version of our resources?
Cool. So that's a really apt question. So large language models has definitely been something that has appeared on everyone's radar, particularly since the beginning of this year. What we really wanted to achieve with these lessons was that we would give this fundamental outline of what made machine learning models work. So whether that would be a large language model or supermarket AI, that this data-driven approach makes students understand specifically how these things work. So when they're using large language models such as ChatGPT or Bard, then they can think about, be a bit more disseminating about what data is used to train these models. That said, so large language models are not covered specifically in this unit, but we have actually developed a set of activities based around large language models that we hope to deliver in the near future. They are currently in pilot, so keep an eye on the website. We're going to be launching them on the website as soon as possible.
Excellent. And then we have a couple of other questions that have come in. We did have one about the AI art generation, which I think you meant, which you've responded to already, in that if you find a tool that works better for your classroom where we've suggested something, use that, because it's more around the discussions that we've got in there, and we will be updating the resources as we find better tools as well. Another question that we've got is, are these resources going to be translated into other languages?
Yeah, so again, a really timely question. So this is something that we're super interested in at the moment. So it's a case of watch this space. We are fully aware that people want to use these internationally. So please, just like the large language models, keep an eye on the website, keep an eye on the updates that are coming soon. And if you haven't already, please sign up for Experience AI, because as soon as you sign up for the platform and the resources, you'll be getting the emails that keep you updated about all the things that we're doing right now.
Yeah, and we are reviewing our materials. You know, we're looking for where do we need to update a particular tool or software that we've used. We're also looking at what the next steps are going to be. We're going to be building on the research that we're going to see from the University of Cambridge, but we also need your suggestions. When you've delivered these in the classroom, we really want to hear your feedback. So under every single lesson plan, you will find a link to a feedback form that you can share your experiences with, and that will help inform what we do next.
Cool. Okay, and I've seen another question come in there. Will the resources be available to the students directly? These lessons themselves are meant to be delivered by a facilitator, whether that be in a classroom or a club. So it's hard for the students to access them directly as such, but we are in the process of developing an AI challenge as well. So that will be definitely for the students to take part in. Those resources will be available to them directly. So these set of resources that we've shown you here are meant to be kind of facilitated by by an educator. But please, again, keep an eye out, because we are developing this challenge where students can definitely access these resources directly and have a go themselves. Cool.
Excellent.
Okay.
I think that's all our questions. Thank you very much, everybody, for sending those in. And that is our whistle-stop tour of all 6 lessons. Hopefully they've given you a good idea of what you can expect and how things run, and given you the confidence to actually go and use them with your students.
Definitely. And remember that we are here to support you in delivering them. These are free resources that come with detailed lesson plans, which are written to give you guidance on how to deliver the unit and the lessons, and the kind of discussions that you can have with your class. So we also have links on the lesson plan for you to provide with feedback, and we guarantee that we are reviewing those feedback comments regularly. And so please help support us by letting us know if something didn't quite work out for you in the classroom or for your students.
Please do. Yeah, we definitely want that feedback. We're also going to be hosting more of these webinars in September. We've got all sorts of topics lined up for you, including AI and machine learning models and engines, bias and ethics, tools to use in your classroom, and more.
Okay, so that's us for this session. So I really do hope you'll join us on a future webinar that we do. And I hope you found that useful. And I hope also that you feel like this is something you want to deliver to your students and you feel confident in doing something. So that's it. So thanks very much, Katie.
And you, Ben. Thank you very much.
Right.
Bye.
Bye, everyone.